Welcome to tutorial number 8. We will solve problems on the topics which we covered in the last week. We'll do problems on magnetic forces and also on applications of Biot-Savart's law and also Ampere's law. Moving on. This is your first problem for today. The problem states that a charged particle of mass 2 kg, which means m is equal to 2 kg, charge is 3 coulomb, starts at point, this is the initial point, with velocity, this is initial velocity, in an electric field, this is E. Do remember, this is electric field, which means it is E. Determine the following: acceleration of the particle, velocity of the particle, and kinetic energy. Right? So what he has given here, he has given m is equal to 2 kg and q is equal to 3 coulomb. He has given initial position. Initial position is 1, minus 2, 0, and he has given initial velocity. It is 4ax plus 3az meters per second. And he has already given E, which is 12ax plus 10ay volts per meter. And he wants to determine the acceleration of the particle at time t is equal to 1 second and also velocity of the particle. These type of problems, these are basic kinematics problems. If you see, there is an electric field and the charge is moving in this field. Since there is only electric field, we know that in an electric field, charge force experienced by any charge F is equal to QE, right? There is no magnetic field present here, so I will limit myself to QE. If there was a magnetic field, then the equation was QE plus Q into V cross P, right? This was electric force, this was magnetic force, right? Now, F is equal to QE, and the same force in kinematics, it can be also written as mass into acceleration. I think you do remember this equation. F is equal to mass into acceleration, which might have studied in your plus 2. So now I will equate these two. M is equal to QE. Acceleration is a vector, E is a vector. Try to remember that one. So A is equal to Q by M into E bar. So this is the expression for acceleration. I do have charge which has been given, mass is given, E also has been given for me. Right? So what is charge? It is 3 coulomb. What is mass? It is 2 kg. And what is E? E is given as 12ax plus 10ay. Right? So what is acceleration A? Acceleration A can be determined using this formula. Q is 3 by 2 into 12ax bar plus 10ay bar. Right. So what we will get here? This is 18ax bar plus 15ay bar. This is acceleration, meters per seconds per. Okay. So which means that there is an acceleration in x direction and also in y direction, and in z direction there is no acceleration. Okay. So I will rewrite here. Acceleration is equal to 18ax plus 15ay meters per seconds per. So the first part has been completed. Now we will move on to second part, which is nothing but velocity of the particle. Coming to velocity of the particle, how to determine velocity of the particle? You know that in kinematics, we'll again go back to kinematics, right? We know that dv by dt is equal to acceleration, isn't it? The change in velocity, the rate in change in velocity is nothing but acceleration. So from this what we can write, v is equal to integral of a dt, right? Plus some constant. This is some random constant, right? I'll employ this formula now. Okay. So v is equal to integral of a dt, isn't it? Now, what I will do, you see, velocity is equal to integral of, what is a here? A is 12ax plus 10ay dt plus c. Now, if you carefully see, this is a vector and it can't be done in this fashion, right? So that's why what I will do is nothing but I will write this one as in different components, vx, vy, vz in three different components, and vx is integral of ax dt plus c. Similarly, vy is equal to in y direction. I will consider in three separate directions. Okay, so I will do in this way. Now, if I do in this way, what I will get, you see here, vx is equal to integral of ax dt plus c, right? Vy is equal to integral of ay dt plus c. Vz is equal to integral of az dt plus c, which means acceleration in x, y and z direction. We have already obtained acceleration, right? Acceleration was 18 ax bar plus 15 ay bar meters per second square. There is only, this is ax component, this is ay component. So what I will get here, this is integral of, I will take it as cx, cy and cz in three different components, right? So this is vx is nothing but 18 dt plus c. So what I'll get here, I'll get it as 18t plus c, right? This is also integral of ay is nothing but 15 dt plus some component, it is 15t plus c. Here I don't have any component of z here, so I'll take it as 0 dt plus c. So what I'll get, this is cx, cy and cz. So these are the velocity components in x, y and z directions. Now I will employ initial conditions. Initially, it has been mentioned, right? If you carefully see, it has been mentioned that it was starting, the charge was starting at this point with initial velocity. This was the initial velocity, okay? So initially, at time t is equal to 0, this was the velocity, which means at time t is equal to 0, vx was 4, vy there was no vy, and vz was 3. See, this is ax component, this is az component, there is no ay component. So I will utilize these conditions now. So I will substitute here, vx is equal to 18t plus cx, right? So at time t is equal to 0, vx is equal to 4. Therefore, what is cx? If I substitute here, what I will get, cx is equal to 4. Initially, vy is equal to 15t plus cy, right? So at time t is equal to 0, vy was 0. So cy was 0. At time vz, it was cz only. So vz was 3. So what I'll get, cz is equal to 3. So my components are 4, 0 and 3. These were the initial values. So I will substitute them now. So what I'll get now, vx is equal to 18t plus 4 and vy will be 15t and vz will be just 3. See. So now what is my v vector now? It is 18t plus 4 ax bar plus 15t ay bar plus 3 az bar. This is meters per second. Understood now? So if I want at time t is equal to 1 second, at time t is equal to 1 second, Now see here, what is this? If I substitute time t is equal to 1 second, what I'll get? 18 into 1 plus 4, this is 22 ax bar, plus this is 15 ay bar, plus 3 az bar. This is my velocity at time t is equal to 1 second. Right? And he's asking me again kinetic energy. What is the formula for kinetic energy? What is the formula for kinetic energy? Can anybody say me what is the formula for kinetic energy? Yeah, half mv square, right? Half m I already have, it is 2. This is v square, this is my v component. So what I should do here, I should consider only mod v square, because kinetic energy is a scalar component, right? Mass is directly a scalar, I have taken it as 2. Now mod v square, what is mod v? It is square root of 22 square plus 15 square plus 3 square whole square. So this is at t is equal to 1 second. At different seconds, then it may be different. So what I'll get, 2 will go, this value what I'll get is, let me do the calculation here. But 22 into 22, it is 484 plus 15 square, it is 225 plus it is 9, right? So it is 718 joules. This is kinetic energy. Okay, so this is my velocity at t time is equal to 1 second, and kinetic energy is my 718 joules. This is the way how we do the problems. Okay, now this ends the problem. But let us suppose if he asks us to determine the position also. If he asks us to determine the position, now we have got v, right? At time t is equal to 1 second, he wants us to determine the position also. Right? He may ask us to do these things. We know that position is dx by dt is equal to v, right? Dx by dt is equal to v. V, I have, see this is my x is equal to integral of v dt. Again, I will go with c. So this one also, I will take this one as displacement. So it will be having in x direction, y direction, and also z direction. In x direction, what you will get? Vx dt plus c. This one is integral of vy dt plus c. Integral of vz dt plus c. This is x direction, y direction, z direction. Now, I already had Vx, right? What was Vx? It was 18t plus 4 dt plus Cx. So what was this equation now? This was 9t square plus 4t plus Cx. This was x. This was 15t dt plus Cy, right? What I'll get here? 7.5 t square plus Cy. This one is integral of 3 dt plus Cy, right? What was this one? 3t plus C. So this is Z. So these are my displacements in x direction, y direction, and z direction. Now again, what I will do, I will apply initial conditions to determine these constants. For displacement, what was the initial condition? Initial condition was 1 comma minus 2 comma 0, right? It was 1 comma minus 2 comma 0 initial conditions, right? So if I substitute it here, what I'll get? See here. What was x6? Yes, it was 9t square plus 4t plus cx, right? xy was 7.5t square plus cy, whereas xz was 3t plus cz. Initial condition was at time t is equal to 0, initial position over 1 comma minus 2 comma 0. So if I substitute it here, at time t is equal to 0, what is xx, guys? It was 1, right? Which means it is cx. xy was minus 2, which means it was cy. I am substituting here t is equal to 0 and xy value is minus 2. And here xz is equal to 0, that is cz. So these are the values of cx, cy and cz. So what I'll get now? So what is xx now? 9t square plus 4t. So I'll write it as x completely. This is plus 1 ux bar plus this is 7.5 t square minus 2 uy bar plus 3t, it is 0, right? 3t uz bar. This is my position. At time t is equal to 1, what is x position? If I substitute time t is equal to 1, then I'll get 9 plus 4, 13, 13 plus 1 is 15. Sorry, it is 14, right? Yeah. 14 ux bar plus this is 5.5 ui bar plus 3 uz bar. This is my position at time t is equal to 1 second. Okay. I hope you have now understood how to solve this type of problems. In examination, I will give both electric field and also magnetic field also. Okay.